In this video, we're going to use substitutions in order to solve two very different looking equations. Let's start with the first one. Here we'll solve x to the 2/5 equals 2 minus x to the 1/5. The first thing I'd like to do to get started is get all of my terms on one side so that I have 0 on the other side. So that will leave us with x to the 2/5, adding the x to the 1/5 to both sides, plus x to the 1/5, minus 2 equals 0. Now, you're welcome to factor this as it's written, but a lot of my students find it easier to use a substitution. And the substitution I'm going to pick the letter A because A isn't in this problem yet. And I'm going to let A be x to the 1/5 in the middle. And what I want to point out is this equation here is what we call in quadratic form. It isn't a quadratic equation because 2/5 and 1/5 do not give us exponents in a quadratic equation, but this first exponent is double the middle exponent. So we call that quadratic in form. If we make a substitution where we let a new variable represent x to the 1/5 in the middle, notice that a squared would be x to the 1/5 squared. And don't forget, when you raise an exponent to another exponent, we multiply. 1/5 times 2 is x to the 2/5. So rewriting our equation with the substitution of a equals x to the 1/5, we have x to the 2/5 is now a squared, plus x to the 1/5 is plus a, minus 2 equals 0. That is a much nicer equation. I can factor that really well. The two numbers that multiply to be -2 and add to be 1 are 2 and -1. So this factors really quickly to a plus 2 and a minus 1 equals 0. And solving for a, I have a equals -2 and a equals +1. Great. The only problem is we need to go back to x's. So let's write this up here. A equals -2 and a equals +1. And go back to what a was representing. A was representing x to the 1/5, which is now equal to -2. And instead of a, x to the 1/5 equals 1. Fabulous, almost done. The very last thing to do is to get rid of the x to the 1/5 power and make it just an x to the 1 power. So the way we do that is we raise the 1/5 power to the 5, or 5/1. We have to do the same thing to both sides. And what will happen now is, much like back in the previous steps where we took 1/5 and we multiplied it by 2/1, multiply the exponents together. Here, if we multiply 1/5 by 5/1, they'll cancel. And we'll be left with x to the 1 equals now -2 to the 5th power. That's -32. There's our first answer. We'll do the same thing with x to the 1/5 equals 1. To get rid of the 1/5, I'll raise both sides to the 5th power. The 1/5 and the 5th power are going to cancel on the left-hand side, leaving us with just x. And 1 to the 5th power is just going to stay 1. Great. So we have our two answers, x equals -32 and x equals 1. Let's try one more. Terrific. For our second example, let's solve the quantity 4 divided by x minus 7 squared plus 3 times the quantity of 4 divided by x minus 7 equals 10. Now, same idea here. I want you to notice that the first term has an exponent that is double the second term. So it's harder to see here, but this is also quadratic in form. We have a term that is squared and a term that is linear, x to the 1. So the substitution I'm going to make to be consistent with the last one is I'm going to let a be the term in the middle, 4 over x minus 7. And that also, if you notice, gives us a squared is 4 over x minus 7 quantity squared. So if we were to rewrite our question in terms of a's, we would have a squared plus 3a equals 10. Much nicer. Now, like the previous examples, we have a quadratic equation. We can start by getting 0 on one side so that we either factor or use the quadratic formula. So a squared plus 3a minus 10 equals 0. And fortunately, this does factor, so it'll be nice and quick. Two numbers that multiply to negative 10 but add to be 3 would be 5 and negative 2. So this will factor to a plus 5 and a minus 2 equals 0. So our two solutions will be a equals negative 5 and a equals 2. Well, our two solutions in terms of a's. But just like in the previous one, we need to make sure we solve for x. So a equals negative 5 and then a equals 2. And let's go back to what a was. A was 4 divided by x minus 7. So we'll have 4 divided by x minus 7 equals negative 5. And then again, instead of a equals 2, 4 divided by x minus 7 equals 2. Cool. Now what we have to do is solve for x here. So one thing that we've been practicing this semester is clearing fractions. And just because we have x's in the denominator doesn't mean we cannot clear fractions. We have an equal sign and we have a fraction. So I'm going to clear fractions by multiplying by our common denominator of x minus 7 to both sides. And the whole point of that is that the x minus 7 cancels on the left-hand side with the 1 in the denominator, leaving us with just 4. On the right-hand side, nothing cancels, so we have equals 5 times the quantity x minus 7. Much nicer. Now I can solve for x pretty easily, distributing the negative 5 through, so 4 equals negative 5x plus 35. Moving the 35 over to get x by itself, so subtracting 35 from both sides. So we have negative 31 equals negative 5x, and when we divide by negative 5, we have x equals positive 31/5 for our first answer. For the second one, let's give us a little bit of room here, just some division in the two problems. And let's see, same idea. I'm going to multiply by the common denominator of x minus 7 to clear fractions on both sides so that that cancels on the left-hand side with the 1 from the denominator, leaving us with just 4. Unfortunately, it doesn't cancel with the 2 and the x minus 7, so this just stays 2 times the quantity x minus 7. Distribute the 2 through, so we have 4 equals 2x minus 14. And then we can add that 14 to both sides. 18 equals 2x. And dividing by 2, this is much nicer than the last one, x equals 9. All finished. So the main idea is if you have something that's quadratic in form, a term that is squared, a term that is not, and a constant term, you can let your substitution be what we call the linear term, or the term with the exponent of just 1. Make that substitution, and you should get a much easier to solve quadratic equation that you can factor if it's factorable or use the quadratic formula. Just don't forget at the end to go back to all of your x's and then solve those equations to solve for x.